Support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Susie.
And I'm Chuck. If you have math questions, give us a call here in Bakersfield, 636-4357. We've got our phone tutors here until 5:30. San Luis Obispo and outlying areas, you can call toll free at 1-866-636-6284. If it's easier, you can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And we're on social media. You can see us on Facebook and Instagram, and Twitter, and YouTube.
All right, well, you know what? We have, every Wednesday we go out to a different business. And we've been to some great places so far this season. And today's going to be another one. And they actually help us do something specifically for our program. So we'll be going out to Raymond's in just a little bit. We have a very special guest in the studio with us this afternoon. A couple of phone callers waiting to get on, but before we get to all of that, let's first take a look at today's Math in the News. All right, here we go. February 1st.
Yes.
Why are there only 28 days in February?
Because there weren't enough left for February.
I've always wondered that.
Okay, well, here we go.
Okay.
All right. Some believe February only once boasted 29 days, and that Augustus Caesar stole a day so he could add it to August because that was named for him. So he was like, all right, February's got 29, but I want an extra day in August because it's named after me, so we're going to take one from February. That's why that month only has 28. But that's a myth. Rather, 28 days is because to the Romans, the month that kicked off the year was an afterthought. In the 8th century BC, they used the calendar of Romulus, a 10-month calendar. All right, so that's where this began. So on this side right here, we can see that we have 10 months. Starting with March is what and this is the way these were represented then. All right, so you've got March, April, May, June, July, August, September, October, November, and December. And you can see all of that, all right? But that only adds up to 304 days, all right? Back then, winter was a nameless, monthless period that no one really cared for. Planters and harvesters used the calendar as a timetable. To them, winter was useless and not worth counting. So for 61 days out of the year, the Romans would ask, what month is it? And you could say, none.
It's winter.
But they didn't care about that.
They didn't care.
So why have a calendar if you're going to neglect 1/6 of the year? So in 713 BC, he lined up the calendar with the year's 12 lunar cycles, a span of about 355 days. That's where we now get January and February introduced. But no Roman calendar would be complete without some good old-fashioned superstition. All right? The Romans believed even numbers were unlucky. So a king, Numa, tried to make each month odd. But to reach the quota of 355, one month had to be even. February pulled up the short stick because it was simply the last month on the list at that time. So therefore, that gets the 28 days. So you can see right here, they've all got the odd numbers except for February.
February used to be the last month.
That is the final month then. So it's like, all right, you get the even one. Of course, a 355-day calendar has bugs. After a few years, the seasons and months would fall out of sync. So to keep things straight, the Romans would occasionally insert a 27-day leap month called Mercedonius. The Romans would erase the last couple days of February and start the leap month on February 24th. So obviously this is going to cause headaches. The leap month was inconsistent, mainly because Rome's high priests determined where it would arrive and when we would have it. All right? By Julius Caesar's time, the Roman people had no clue as to what day it actually was. So Caesar nixed the leap month and reformed the calendar again. Caesar aligned the calendar with the sun and added a few days so that it all added up to 365 days. And that is why there are only 28 days in February as far as one explanation goes. Now, let's tie in some math to this. So here we have a calendar. This is March of 2013. And what you would ask a student to do is say, all right, I would like you to just pick a block, a four-square, a block of dates, and then tell me what the sum is, and I'll tell you what the dates were. All right? So here's an example of what you could do. Somebody might go, all right, my total is 20. Okay, so you would look and you go, your days are 1st, 2nd, 8th, and 9th. All right? So here's how you could do it. So let's say the 4 dates adds up to a sum of 60. One way to figure out the 4 numbers is the first number will be n. The next number is n plus 1. The next is n plus 7, so you're adding a week to the first, and then a week to your n plus 1. So you take all of that, you've got the first date, the second in the square, the one under the first one, and the one under the second one. You add all of those up, combine like terms, you've got 4n plus 16 is equal to 60. Solve for n, you see that you take away 16 on each side, you've got 4n is 44, n is 11, so we know that the block started on the 11th, so you've got 11, 12, 18, 19, therefore it adds up to the 60.
That's fun.
And that is how we can tie in the math with why there are only 28 days in February.
And who decided that January was going to be the first month and not March?
Well, you know what, because it had been March for a long time, right? So it's like, oh, let's just add these on the end and things like that. Anyway, we do have phone tutors available until 5:30 this afternoon. 636-4357 is the phone number. We do have phone tutors here. And if you call in from San Luis Obispo County and we do one of your math problems on air, you'll automatically receive ice cream from Doc Bernstein's Ice Cream Lab. In studio with us right now, we have Leah. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Buena Vista Elementary School, and I am in 4th grade.
And how is 4th grade?
It's pretty hard.
It's pretty hard?
Easy.
But you're in school a longer period of time now, right? As opposed to being in 3rd grade, so you're there for a little bit longer day.
Yeah.
And what do you think is the most difficult thing about 4th grade if it's a little bit harder now?
I don't really know about how difficult it gets. Like, it's just the same as 3rd grade. It's just doing math all day.
So you're doing a lot of math all day? And do you like doing a lot of math all day? Sometimes it's all right. Sometimes it's like, listen, man, we could do something else a little bit. Maybe some PE or some art or things like that. All right. Well, you know, we'll talk to your teachers about that, all right? You ready to do some work this afternoon?
Yeah.
All right. Well, we're going to make you do some work. You brought in some homework. We're going to take a look at that in just a few moments. But right now, we're going to go out live to Raymond's Trophy with Marylou.
We are live today at Raymond's Trophies and Awards, and I have a special guest with me. Why don't you let everybody know your name and your position here?
Megan Raymond. I'm one of the owners, and I'm the graphic designer and engraver with Raymond's Trophy.
Can you give us a little tour? This is your little area.
This is my area. So basically I run our 30-watt laser, our full color sublimation. I also run our rotary laser on the other side, or our rotary engraver on the other side of the building. But mostly I do the lasers. So this is my workstation. I create all kinds of crazy things over here for you guys.
What are some main things that you create?
I'd say primarily I'm doing signs and plaques. And then any full color design that needs to be done in the store, we do over on this side of the store.
Can you give us a little example of something that you would design for us?
So I actually can do the math sign for you guys. So a lot of times people just want little signs placed around their building. So I am going to do a 3x4 sign for you.
Okay.
Sound good?
Sounds great.
So we work in Corel Draw, and we are PC based. We're one of the few people in the graphic industry that are PC based, which is odd, and people think it's crazy, but it's a little bit different.
So obviously with all the, a lot of things, you have a lot of new programs, don't you?
We have a lot of new programs constantly updating. We have to sync our Corel with our laser engravers all the time, so everything's always changing. But we're up to date with it, and we know what's going on. So I'm going to do a 3x4 sign, and the way I'm going to do that is I know that I have a sheet that's 9 inches by 12 inches. So I know that I can fit that on there exactly the way I want it, and I can get all 9 pieces. So I'm going to butt it up to the corner.
So obviously you have a lot of measuring that you have to do.
We do. We usually, our sheets come in 12 by 24. This particular sheet I had some leftover, so it was a 10 inch, so I cut off an inch of that. So I had a little bit of leftover that we just tossed, but I want to try to get the most signs out of my sheets so that I have very little leftover and very little loss in profit.
Now, when you're saying 12 by 24, you're talking all inches, correct?
Yes, inches.
Okay.
We work solely in inches. Funny thing is that when we send it to our laser, it's a metric-based system, so we do have to convert everything to inches. And they do have a nice button that does that for us. It didn't used to. You used to have to figure it all out on your own, because the laser program is actually a European-based program.
Okay, so you're working with both. You're converting
I'm working
both.
with both, yes. So we have a nice transfer program that'll do it for us. So it tells me that I need 9 total pieces. The blue lines represent my cutout, so my laser will do that for me as well. And anything that's black is what engraves. So an engraver only sees 2 colors, black and white. It doesn't see the in-between like a printer would. But it works very similar to a dot matrix printer. So it goes across the way just like it would in the old printing systems where it just created dots. So basically the laser is shooting off at so many dots per inch.
So on this particular one, is there any leftover, or are you getting it all on the complete page?
I'm going to get it all on the complete page.
Okay. And so it's just black and white, there's no color?
Correct. It's for laser, for any engraving in general, it has to just be black and white. No gray tones, no in-betweens. So next, once I have my whole page set up, I tell it to print, and we have our software already installed. I then have to assign a power and a speed to it. So based on the substrate that we're using, for example, a metal piece would probably engrave a little bit faster than a plastic piece. So I have to do 100% power for plastic and 30% speed, or possibly vice versa, 30% power, 100% speed. If I'm doing glass, I need to really be able to hit that and cut it really well. So I'm going to do a really slow speed of maybe 10% and then maybe 100% power. So we've calculated those over the years, and every time we have to up our wattage or change our bulbs, we have to recalculate all that. So it's kind of time consuming, but we try to keep it up and do the maintenance properly. So this particular one, I'm using a blue plastic. I happen to know that that takes 30% speed and 100% power. We do have another machine that runs what we call hotter. So on her particular machine, she can run it a little bit faster. She can do about 60% speed and 100 power. So depends. If we have a large job, sometimes we'll use her machine.
Well, there's a lot of numbers you have to memorize,
Yeah.
obviously. Memorizing, do you have something that kind of helps you to relate? Like if somebody else steps into here and needs to do it if you're not here, do you have something for them that they can look at?
We keep a little cheat sheet on the side over here because that happens often. Everybody here is able to do everybody's job. Not always as well as the other person, but say I'm sick or our other gals are sick, somebody can always step in and do it. So we've created a cheat sheet just for them because, you know, the manufacturer gives you, this works well. Well, on the West Coast where there isn't as much humidity, it might work really well, but on the East Coast where there's more humidity, that plays a factor in it as well. So, yeah, we use our cheat sheet all the time. So I have to also tell it my my measurement for my sheet so that I make sure my actual machine is much larger than my sheet, so I need to give it the practical size. And then I have to tell it, I already told it was going to be in inches, so I made a 12 by 9. We use an X and a Y axis. All of our machines based on an X and a Y axis, which and you're not real good at that in the beginning, you have to
Yeah.
learn,
Well-
because on our rotary-based machines, all of our calculations are 100% based on X and Y axis.
So
we
obviously that graphing that students are learning, they
had
need
to learn
to
that.
know
Yep,
that.
absolutely. All right. So once I'm good, I send it just like you'd send anything to a regular printer. It goes over here, it calculates. I do have to turn on our vacuum. I'm gonna press this little button right here.
There you go.
The laser is printing just like a dot matrix, so we do it at 400 dpi, which means that's 400 dots per inch.
So how long will this take?
This will probably take about 10 minutes to do a full sheet.
So when we come back, we'll be able to see this done.
Yep.
Yes. And then also when we come back, Megan, you're going to be showing us how you guys create our tile, do the math tiles. All right? All right. Okay, can't wait to see that done. All right, back to you gentlemen at the studio.
All right, well, we'll see more of that in just a little bit. We'll put Leah to work in a little bit also. But right now, we're going to go to the phones. And Trinity, how are you this afternoon? Hello, Trinity.
Good day. Hello.
Yes, how are you today?
Good.
What grade are you in?
7th.
Okay, and you're a student at Stern Middle School, correct?
Yep.
All right, as soon as you're ready, let's hear the math problem that you're working on. Because I think you had a problem,
what was
and then
that?
we're going to give you a problem also, right?
Trinity, what is the problem that you want some help with?
Hello.
Hi, can you give me the problem that you're working on?
I'm sorry, I can't hear you guys.
All right, so can you hear me, Trinity?
Yes, now I can.
Okay, so yeah, just listen, and here's the problem that we're going to have you work on, all right?
Okay.
So Lewis needs $40 for a video game.
Uh-huh.
He has $10, and he makes $9 an hour.
Uh-huh.
So what they want you to do, your worksheet, is write and solve an inequality showing how many hours he needs to work.
Uh-huh.
So do you know how to set up this problem?
Yes.
Okay,
So-
let's see. I think it started with $40. Is that right?
Yes.
Okay. So how is he going to earn the $40 that he needs?
By working 5 hours.
Well, how do you get? Well, he already has how much money?
He has,
He already has 10, doesn't he? From the problem, it says he has $10, right?
yes.
And what's he going to add to that? He's going to work, right? You said
Yes.
$9 an hour. So they want to know how many hours he's going to work, correct?
Yes.
So what are you going to use? We're going to use, we're going to set up an inequality with a variable, right? What do you want to use for your variable? What letter?
Y.
Y, okay. So Y is going to equal the number of hours, right?
Yes.
Number of hours.
Huh?
So if he's going to work Y hours and he makes $9 an hour, how much is he making all of those hours?
He makes, hold on, I'm working it out.
Yeah, he makes $9 in 1 hour, right?
Yes.
So in 2 hours, how much money would he make?
18.
18, that's 2 times 9, right?
Yes.
And in 3 hours, how much would he make?
27.
3 times 9, right?
Yes.
In Y hours, how much would he make?
You would make $36.
Well, in Y hours. We don't know how many hours, do we? It's Y hours. That's our variable. So in Y hours, if he makes $9 an hour, I'm going to take, just like you did, you went 9 times 1, 9 times 2, 9 times 3. We're going to take 9 times Y, aren't we?
Yes.
And this is going to be the money he earns, money earned in Y hours, isn't it?
Yes.
So the problem, I think, that we just said, he starts with $10 already, and he's going to earn some more. That's what this is going to be. And he needs to earn $40, right?
Yes.
But it says an inequality, so can he earn more than $40? He can he? As long as he gets 40, that's good. But he could earn more. So instead of putting an equal sign here, we're going to put a greater than or equal, aren't we? So it asks you to set up an inequality. So it's going to be 10 plus how much he earned is got to be greater than or equal to $40, doesn't it? And we just figured out how much he earned. He earned 9y, didn't he?
Yeah.
So here's your inequality. 10 plus 9y is greater than or equal to, you know that symbol, right?
Yes.
Greater than or equal to 40. Okay, so there's your inequality.
Okay.
Now, do they want you to solve this problem?
Well, it says write and solve an inequality.
Write and solve. So there's the first step, is to write the inequality, and we got to solve it, correct?
Yes.
So how do you solve an inequality? Here, let me get rid of this so we have room. So now we've set it up. Now that we've set it up, let me see if I can erase this. How do you solve for y?
You solve for y by multiplying.
Well, we've got 10 plus 9y is greater than or equal to 40. Do you have that written down?
Yes.
So how do we get that y by itself so we can solve for y? Do they want you to do this by guess and check or solve the problem?
Solve the problem.
Okay, so have you been working with solving these inequalities? You've been solving equations and solving inequalities?
Kinda.
Okay, so let's undo all of these operations so we can get y by itself, right? So the first thing is, how do we get rid of that $10?
By multiplying 10 times 40.
Well, the problem is the 10 is being added to the 9y, right?
Yes.
And so if we want to get rid of it, we want to undo that plus 10. We're going to subtract, aren't we? So we're going to subtract 10 from both sides of this inequality. And just like in an equation, whatever you do to one side, you have to do to the other, don't you? Whoops. Yeah, not 40, 10.
Hello?
Yes. You still there?
Oh, you were breaking up.
So we're going to subtract 10 from both sides of the inequality, okay? Because we want to get rid of the 10 on the left side of the inequality, and that leaves just 9y. Still greater than or equal to, because we haven't changed the direction. And on the right side, what's 40 minus 10?
40 minus 10 equals 30.
So now we have a new inequality. We have 9y is greater than or equal to 30. Right? So we still have to get y by itself. So how do we undo multiplication?
Say that again?
How do you undo multiplication?
By dividing.
So we're going to divide both sides of this inequality by the number we're trying to get rid of, right? We're trying to get rid of that 9. So let's divide both sides by 9.
Okay.
So the 9's on the left side cancel, and we get y is greater than or equal to 30 divided by 9. Now we're trying to find out how many hours, so we're going to change this improper fraction to a mixed number, right? So what's 30 ninths?
39.
How do you change 30 ninths to a mixed number?
By dividing?
Right, because 30 over 9 is the same as 30 divided by 9, isn't it?
Yes.
So we're going to take 30 and we're going to divide by 9. And so you were doing this problem at the very beginning. You did it trying to do it in your head, trying to put in the number of hours. Maybe he worked for 4 hours or he worked for 5 hours. Let's see how many hours he has to work. 9 goes into 30. How many times?
9 goes into what?
9 goes into 30. We're doing 30 ninths, right?
Oh, 9 goes into 30. 3 times.
3 times, because we know that 3 times 9 is 27, right? We did that with the hours. So what do we have left over is 3 ninths. So instead of doing this as a decimal, let's do it as a fraction. The remainder of 3, so our fraction is the remainder of 3 over our divisor of 9, right?
Yes.
So it's 3 and 3 ninths, but 3 ninths reduces to what?
Say it again.
What does 3/9 reduce to?
3/9 reduces to 3.
Well, let's see. We'll divide top and bottom by 3, and the 3 is going to be on the bottom, isn't it?
Oh.
So that's going to be 3 1/3, isn't it?
Yes.
So here's the question. If he wants to earn $40, how many hours does he have to work?
He has to work 5 and 4.5 hours.
He's got to work 3 1/3 hours.
Oh.
If he works 3 1/3 hours, he can make enough money to earn that video game, right?
Yeah.
But suppose he had to work a whole number of hours. How many hours would he have to work? 3's not enough, right?
Yeah.
So if he had to work a full number of hours, I think he's going to need, did I just lose it? He's going to work 4 hours is probably the whole number answer that you're going to, right?
Yeah.
So I think we had y is greater than or equal to 3 1/3, and 4 hours would be the number of hours he's got to work. Okay? Great problem.
There you go. Nicely done. You didn't have to work 3 1/3 hours in order to get yourself a great meal, courtesy of our friends at Chick-fil-A. So congratulations on that. Hey, we do have phone tutors available until 5:30 this afternoon. Right now, we've got Leah in studio, and we're going to do some of her homework right now. So we've got the first part of it up on the screen. So maybe I think we can just basically talk about this part right here. So Susie's going to work with you, Leah, in case you need some help, all right? So it says moving around. Have you ever gone to a dairy and seen cows up close?
Well, no. I've only passed by, like when we're driving, I've only seen cows. I've not gone close up to one.
Well, perhaps in the next year, you might have an opportunity to go do that. Never can tell, huh? All right, let's take a look. We've got Bessie, Flossie, Sadie, Daisy, Moosie, Susie, Lucy, and Bella. Question number 1. One herd has 4 black cows, some with spots and some without. What are their names? So, Leah, taking a look at it, what do you think the names are? There are 4 black cows, some with spots and some without. What are the names of those cows? So can you see the paper either up on the screen or right here?
No.
No? Okay, here's what we'll do. We'll just move it for you right now.
Well, it's Bessie, Flossie, Sadie, and Daisy.
Okay, so that one's all set.
Yeah.
All right, let's take a look at number 2. We'll put it up here so the kids at home can play as well. Another herd has 4 white cows, some with spots and some without. What are their names? So, we'll take a look at this once again for you.
Moosie, Susie, Lucy, and Belle.
Okay, so far those first 2 questions seem pretty straightforward, right?
Yeah.
What are the black cows? Some are, solid, some have spots. What are the white ones? Some are solid, some have spots. All right, so that's pretty easy, all right? Let's take a look at number 3. 4 cows went to the fair, all had spots. So now we need to figure out which 4 went to the fair because they had spots. Which ones are those?
Susie, Flossie, Daisy, and Belle.
Okay, are you sure about that?
Yeah.
Susie, you agree with that?
I agree.
All right, so let's take a look at number 4. So 4 cows usually stand under the apple tree, all have horns. All right, so here we got nothing to do with spots. All have horns. All right, so which ones would that be?
Susie, Flossie, Bessie would be.
And you need one more. So you've got Susie, Flossie, and Bessie.
And Moosie.
And Moosie.
Right.
All right. So Susie agrees with you on that one right there. So we've got the first 4 of those figured out. But you've got 6 more questions that are going to get increasingly more difficult as we go along. Yeah. You ready for those later on? All right. Hey, we'll be back with more of those right after this. And once again, we're at Kern Schools Federal Credit Union. We've got Nora and Anish with us today. And also helping us out, we've got Kiana.
Hi.
Nice to see you once again. Now, we have opened an account. We've learned a little bit about simple and compound interest, and the students recently learned a little bit about debit cards and the difference between using it as a debit or a credit card. And right now what we'd like to do is, because you guys probably would get in a pretty easy habit of being able to spend money as you got it, but now what we want to do is plan a budget. Okay? So Kiana's going to help us out with this a little bit.
Okay, great. Do you guys know what a budget is?
Yes.
Yes?
I think so.
You do? Okay. Well, we'll go over it a little bit. You want to make sure that you have a budget so you know exactly how much you're spending and what you have in the account. Because if you spend more than you have in the account, you may get fees, and we don't want to have any fees. So I'm going to give you guys a check register, and this is going to help you keep track of how much money you have in your account. Okay? On the check register, you're going to put the balance that you have in the account. And then every time you make a purchase, you're going to write down what you spent and where you spent it. So if you have $500 in your account and you spend $100, are you taking that money out or are you depositing it?
Taking it out.
Taking it out. So what will your balance be after you spend $100 off your $500 balance?
$400.
$400, exactly. So you want to make sure that every time you spend your money, you're writing it down so you know how much you have in your account so you don't get a fee. Does that make sense?
Mm-hmm. It's like a record book, right?
Yeah. Exactly. So say it's your birthday and your parents give you cash for your birthday and you come in and deposit that. You want to add that back into the balance that you have so that you know that now you have more money.
So you're just keeping track of every transaction, whether it's a deposit, where you're putting money into the bank, or if you've made some sort of a withdrawal, meaning you came into the bank and actually took money out, or when you used your debit credit card, you used your debit card and you spent money someplace, then you would have to make sure that you took that money off of your account.
That makes sense.
Perfect sense, huh?
Yeah.
Do you guys have any questions about your registers and how you're going to use them?
No. Nope.
All right. Well, everybody has a different type of budget that they use and how much they budget for different things, because as you get a little bit older, you're going to want to think about, okay, if you're driving, you need to think about expenses for your car, so you need to budget that. Then if you have some activity that you like to do, you need to budget money for that.
Yeah, so budget is good so you know exactly how much you have, where you're spending it, and so that you're not overspending.
And Kiana, thank you very much for budgeting today.
No problem. You guys have a great day.
Thank you.
It's basically paying and receiving. Members will come in, they'll have checks, they'll want to either deposit or get money back for the check. Those are the main types of transactions that take place.
All right, and we're back, and you know what? We've got some more problems to do with Leah as far as the cows go, but we're not going to do those right now. We'll give you a couple of minutes to get ready for that, because right now we'll go out once again to Raymond's Trophy and Marylou.
We are back here live at Raymond's Trophy and Awards, and I'm with Megan. And when we left last time, we were obviously making a sheet of our word logo, Do the Math. And it's still continuing, and it's pretty cool watching it go with that little arm back and forth. So it has a little bit more to go, doesn't it?
Just a little bit, yeah.
Now, you also do our plaques.
I do.
And there's some history behind this, because Mike had sent you our logo and asked you to design our plaque.
He did. I knew your colors were blue, and he sent the logo and said, just give us something that we can give our guest speakers as they come in. So I wanted to create a background that was tangible to math, of course. I was hoping all the equations were correct. And then I just send him a proof, and he looks at it, and he makes sure he likes it, and then we're good to go.
Well, can you show us how you did this?
Yes. So it's same program that we did our other signs in. We just do it on a full color basis. So this time I can use color. So I start out having to know the size of my product. So the tiles that we do come in a 4.5, a 6.5, 6 by 8, and an 8 by 8 size. So I've got several different product I can use. We did a 4.5 for this one. So we create a couple of filters, and I did some transparencies, but ultimately we had to make sure that the Do the Math segment, which isn't actually white, it's sort of a gray, was the right PMS color, which is a way of measuring your colors on the color wheel. And then once Mike approved it, we went from there. So once we design it, I go ahead and send it to another printer. So this printer for engraving is right here. This piece is going to go to a color printer across the way.
Okay, can you show us that?
Yep, let me send it. All right, so it travels across the way and it goes right over here. So we have two size printers. We have a small format and a large format. And it's a regular Ricoh printer like you can buy in any Office Depot. We just switch out the inks. So we essentially void the warranty, but we change the inks to what we call a sublimation ink, which is actually not really an ink. It's a chemistry process that happens. And so
what is sublimation?
Sublimation is the transfer of a solid to a gas to a solid again. And it has to have a poly coating on the material to be able to accept that. So each substrate that we use, there's tile, there's badges, there's lanyards. Each substrate has to be pressed with a certain amount of pressure to transfer the gas, and a certain amount of heat and a certain amount of time. So the tiles, you have to heat up a lot longer, so it's about a 6-minute process. A badge is about a minute process. A piece of material might be 40 seconds. And that can give or take based on the region you're in as well. So again, West Coast is a lot more dry, so there's not as much water in it, so it can go a little bit faster. East Coast might take a little bit longer because your materials might have some moisture in them.
Now, do you use normal copy paper?
We do not. We have to buy specific paper for the process, because when it comes off, it's dry. It feels just like ink, but the odd thing is it's not an ink. And we do have to mirror it, because then when we set it on the product, it comes up right side up. So
okay. That's why it's kind of backwards.
It's backwards.
Okay, so once there, what do we do with that?
So once there, this is our heat press. There's lots of different ones you can use. We happen to love this one. It's a swing arm, so it's really nice for us to work with a full area.
And it's warm.
It's warm.
I can feel the heat.
400 degrees is pretty much the sweet spot. That's what we use for everything here. Again, depending on your region, it can change. So because tiles can break so easily, we have to put a couple of towels on there, and then we use a piece of
so it's like parchment paper?
Yeah, it's like a parchment paper, so that if the ink transfers anywhere else, we can just wipe it right off. Because you always want to have a little bit of a bleed from where your tile's going, so that you make sure that your ink goes all the way around to the edge of the tile.
So you've started with a complete white tile.
Started with a complete white tile. It has a poly coating on top of it. You can get a matte or glossy, and then the ink will turn into a gas, and then it'll turn back into a solid.
So once you put this down on it, how long will that stay?
This particular one will take 6 minutes.
Okay. So that goes on it, and that's going to stay for 6 minutes.
6 minutes.
And then once that's done, does it come out
exactly like that? Exactly like that. It'll come out, it's hot, it's 400 degrees, so it takes about 5 minutes for something like that to cool down. A sheet of metal takes about 2 or 3 seconds. We can throw it on a piece of another aluminum and it cools it off really quickly.
So almost like a cake, you gotta let it cool.
Yep, you gotta let it cool.
Well, Megan, thank you. This has been
You're
amazing
welcome.
to see, especially our tiles, because this, this is near to our heart.
Yeah,
and
dear.
you designed them. Thank you so much.
You're welcome.
They're beautiful. And then when we come back, we're going to be seeing how they create a trophy. So back to you at the studio.
All right. Well, I know that they do a lot of trophies, a lot of different awards. They've been around Bakersfield for a long time, a family-owned business. Always work with a lot of different groups, and Raymond's Trophy well known, and I know that we appreciate them helping us out with our tiles, but a lot of different things that they do down at Raymond's Trophy. So we'll check out some more of that with Marylou and Megan in just a little while. Right now, we'll go back to the phones, and Jocelyn, how are you this afternoon? Hello, Jocelyn.
Hello.
Are you in 7th or 8th grade?
7.
All right. As soon as you're ready, let's hear the math problem that you're working on. So you go ahead and read it.
Okay, 1/4 divided by 3/2.
I'm sorry, 1/4 equals?
Divided by.
Divided by?
3/2, I think she said.
Was that a 3/2?
Yeah.
Okay. So I wrote the divided by as the divided symbol, the line with the 2 dots, right?
Yeah.
Okay. So you're dividing fractions. 1/4 divided by 3/2. So the question is, how do you divide fractions? What do you have to do to get the answer to a dividing fractions problem?
Divide.
Divide. So what am I going to divide by? 3/2, right?
Yeah.
So what do we have to do to this division problem so we can solve it? What's our first step?
1 divided by 3.
Well, I've got 1/4 and 3/2, right?
Yeah.
So I've got to change this problem. Well, I have to change this dividing fractions problem into a different problem, right? So have you been working with changing it to multiplication?
Yeah.
So we're going to change it to multiplication. And so there's a couple ways of doing it. I know that they work with the 3 numbers. We don't change the first fraction, do we? But we have to change the second fraction, don't we? So I'm going to take that 1/4 and leave it alone. And what am I going to do with that 3/2? That 3/2?
Wait, a 3/2?
Yeah, we keep the 1/4, but we have to change that 3/2 and we have to flip it, don't we? So we have to change it to 2/3.
Yeah.
So do you guys work with keep, change, flip? Have you worked with that?
Yeah.
I don't know, is it KCF? You keep the first fraction, right? You change the division. What are we going to change that division to?
Times.
Times, and we're going to flip the second fraction. So once you get past keep, change, flip, what we're doing is we're multiplying by, do you know what you call it when you turn a fraction over?
No.
We change that and we make it the reciprocal. We take 3/2 and we make the reciprocal 2/3. So we're actually multiplying by the reciprocal when you change the operation and flip the fraction. So now what we have is a much easier problem. We have multiplying fractions, don't we?
Yeah.
And when you multiply fractions, do you multiply and reduce or do you reduce first? When you guys did
multiply and reduce?
Yeah, so let's multiply and reduce. So the multiplying is easy, right? Multiply the top 1 times 2, that's easy, that's 2. And the bottom is 4 times 3. Also easy, that's 2, that's 12. So your answer is 2/12, but we have to reduce it, don't we? How do you reduce 2/12?
Divide.
Divide. What am I going to divide the top and the bottom by?
Divide, let me see.
So we have
Divide
to,
by 2, right?
yeah, we have to divide by the same thing, right? So what goes into both 2 and 12? 2, right?
No.
2 divided by 2 is 1 on top, and 12 divided by 2 on the bottom is 6.
6.
So you got your 6 and it's on the bottom, so your answer is 1/6, isn't it?
Yeah.
So you could do the problem by multiplying and reducing, or you could have reduced first. So sometimes you'll see a problem like this, and you can't reduce 1 and 3, but you can reduce the 4 and the 2. Notice from corner to corner, 2 divided by 2 is 1, and 4 divided by 2 is 2, and we can reduce by canceling those corners, and we still get 1 times 1 is 1, and 2 times 3 is 6, and we get the same answer. So your answer is 1/6. Okay? Thanks for the call.
Now, Jocelyn, before you go,
Yes.
are you still online with us?
Yeah.
All right, because 1/6 will be an answer on a standardized test.
Yes.
Another answer will also be 3/8. So write 3/8 somewhere on the board there, Chuck.
3/8?
Right. And Jocelyn, see if you can figure out from the original problem why 3/8 would be a possible answer to that problem. Are you able to see the problem still? 1/4 divided by 3/2?
Yeah.
Okay, how do you think they might come up with 3/8 as an incorrect answer, but one that they would put on there?
So can you look at the original problem. What could you do in that original problem to get the wrong answer of 3/8? Do you know?
Divide it?
Well, we multiplied here 1 times 2 to get 2 and 4 times 3 to get 12. But what could you have done with the original problem to get 3 and 8?
Oh.
There we go. That's what I was looking for. Okay.
You see what you could do with these numbers to get 3/8?
Yeah.
If you take the 1 and the 3 and multiply them, what do you get?
1.
And if you
What's
take
it say?
the 4 and the 2 and multiply them, what do you get? So sometimes they'll give you multiple choice questions, and one of the wrong answers of 3/8 would be to take that original problem and just multiply it, right?
Yeah.
And if you forget to flip that second fraction, you'll get the wrong answer, 3/8. But it looks pretty good with the numbers that they gave you.
Right. So anyway, I just wanted to see if you could take a look at that real quick, Jocelyn. Congratulations also for that fine problem. You'll be receiving a meal courtesy of our friends at Johnny Rockets. So congratulations on that. Hey, we do have phone tutors available until 5:30 on Tuesdays and Wednesdays throughout most of the school year. Phone numbers are at the bottom of the screen periodically throughout the program. And I wanted her to do that because a lot of kids will go, all right, we're dividing fractions and I know I have to do something and multiply.
Right.
So if I just multiply right now, I could see I could get 3/8, and I think that's why they would probably have an answer like that.
And usually 3/8 would be the first choice of those multiple choice questions.
Right, something like that. You're not going to make that mistake, are you?
I don't really know about the equations.
You don't know about that one? Well, you
We're
don't have to
not-
worry about that. You're only in 4th grade right now.
We're not that far.
Well, you will be. Let's take a look at your problems again, all right? Because we've only done the first 4 of these cow problems, all right? So you and Susie are going to talk about these problems. So you've got a copy that you can look at, and we're going to leave this one up on the board so that the students at home that are playing along can see if they can figure that out as well, all right? So we're on question number 5, and I know that the students can't see, but it's more important for them to see the cows on the board. So number 5, 4 cows had calves in the spring. None of the cows had horns. What were their names? So go ahead, what ones do you think it were?
Okay, I think they were Lucy, Belle, Daisy, Sadie.
And what do you think? So you've got Susie right there to help you and confirm with things that are on this, all right? So number 6, all the cows with spots and all the cows with horns came into the barn when it rained. Name the cows that did not.
Okay.
Okay, I think the cows that did not were Sadie and Lucy.
Okay, so let's check that. So the spots and the horns came into the barn.
Oh.
So
And
one
the
of
cows that did not.
Yeah, it's okay to mark on here. Sometimes you just need to mark and keep track of what you're doing. So spots and horns came into the barn. So yes or no? Horns.
She went in.
Okay, spots and horns. Okay,
No.
no. Okay,
Yes. 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 No. Yes.
no, now you got it, huh?
So we want to know the cows that did not go into the barn. And what ones were those?
They were Sadie and Lucy.
All right, so we've got that one down. Number 7, the black cows, the cows with spots, and the cows without horns do not wear bells. Now, who ever heard of a cow without a bell? You
Yeah,
kinda know,
right. That's right, cowbells.
Anyway, which cow wears a bell?
Okay.
So
the-
black cows don't, cows with spots don't, and cows without horns don't. So we want to know
That's
who wears
Bessie
the
and
bell.
Flossie and
I
Sadie
think
and
that-
Daisy.
I think that's Lucy.
I think you're right. Cows without horns? Yep, I agree. It's got to be Lucy.
All right, so here we go. On to question number 8. At night, all the cows came into the barn but one. The white cows, the cows with horns, and the black cows without spots came in. What cow was missing?
Okay. So,
Want to start over again here?
yeah.
Okay, well, do you want it so the white cows?
So the white cows came.
That'd be
Okay,
all 4 on the bottom.
cows with horns.
So Bessie and Flossie can't
Flossie.
go.
Okay, and the black cows without spots came in.
So Daisy was the only one left.
That's right.
So who was missing?
Daisy.
All right, so here we go on to number 9. There's a lot of stuff to keep track of, isn't it?
Yeah.
So all math doesn't necessarily have to have numbers because you're reasoning and using logic right now to figure out all these cows. All right, here we go. Each of the farmer's 2 kids had a favorite cow. Both cows had horns and spots, but were different colors. What were their names?
Okay,
So who has horns and
Flossie.
spots?
and Susie have horns and spots, and they're different colors.
That's right.
Right, and different colors, that was the key right there. All right, here we go. On to the final one. You ready for this?
Yeah.
This is a long one. 7 cows went for a walk around the pasture. The black cows with horns, the white cows with horns, and the black cows with spots went. The black cows without horns and the white cows without spots also went. So we're trying to find the cow that did not go.
Belle did.
You came up with that pretty quick. Let's take a look. You know what I want you to do? I want you to come over here, and I want you to start marking this off, all right? So grab your pencil, just come over here and stand right here. You can stand wherever you like to so that you're comfortable, all right? So here we go. 7 cows went for a walk around the pasture. The black cows with horns, all right, so you can mark it however you want. The black cows with horns, the white cows with horns, the black cows with spots, the black cows without horns, white cows without spots. So which cow didn't go?
Belle.
There you go. So nicely done. So come on back over here. And how do you like doing problems like that? Because it's a type of math, but you had no numbers at all that you were working with. So do you like those type of problems?
Well, they're okay, but I'm more like the problems where you're multiplying.
So you like multiplying a little bit more, right? Okay. And I know that in studio with us, you brought your brother along for the trip, and he's over on the board, and he's got a ton of multiplication problems that he's working on right now. And I think they've got a camera on him over there, actually. And what's his name?
Dylan.
Dylan? Yeah. And how does he's in 2nd grade, but he's got a lot of multiplication problems going on there. How does he learn his multiplication?
By coming up to me and saying, what
so he's asking you, all right, what is
Yeah.
this, right? Because he's got some addition problems on there right now, but he was doing 2 times 2 is 4. But then he had 10 times 10 was 100. And then he was going 100 times 100. So did you teach him how to do that, where you can just add some zeros and get answers like that?
Well, I was the one who taught him how to multiply, like this number times this number.
Okay.
So you have to add this number that many times.
Right, so repeated addition, right?
Yeah.
So that's one way to do it. And is that how you learned also, or is this just another way that you came up with?
That's how I learned. My cousin one night, we were seeing who, like I was telling him problems, and I'm like 100 times 100.
Oh, good. So you guys came up with a game and you guys kind of get into this thing?
Yeah, and
All right.
I was like, what is multiplication? It's like, it's this, that addition this many times.
Perfect. So that's how you learned, and you're passing it on to your brother now.
Well, I pass it on to many other kids.
Well,
I was like, I was at school, I would go to the playground and be like, you know how to multiply?
So you're spreading the good news of multiplication.
That's right.
All right. Well, you know what? We're going to come back with you in a few moments. Right now, we're going to head back out to Raymond's Trophy with Marylou and Megan.
We are back live at Raymond's Trophies and Awards, and I have another special guest with me. Why don't you let everybody know your name and your position?
Randy Raymond, and I'm the owner.
And how long have you been here?
I've been here since day one, so 24 years.
Wow.
And it started with my mom and dad, and they've turned the business over to my brother and I about 3 years ago. And so it's been a long process, but it's been a fun process.
Same building.
Same building, all 25 years.
Now, you have a lot of different components that you do here, right? Because with Megan, we saw some things that she did with the posters and the tiles. And can you kind of tell us what we have here in front of us, this machine here?
This is another engraving machine, which engraves a lot of the trophy plates that we put on trophies and stuff. And so if you push the button, this certain trophy order has like 60 or 70 trophy girls like that. This plate here is 12 inches by 16 inches, and it has all 70 plates that are on the actual plate.
So this is going to go on a trophy, right?
Eventually what we'll do is we cut them down one at a time to go on an actual trophy.
And can you kind of show us how you make a trophy?
Sure. So this is what a trophy column starts out as. It's 48 inches long, and what we do is when we get a trophy order, like on our computer screen here, it shows that we need 15 first place trophies, 15 second place trophies, and 15 third place trophies. Obviously, first, second, and third place column have different heights for the column, different sizes for first or second or third. So we go in the back. Ramon, who is our trophy assembler, he would go back in the back room and cut these down individual pieces.
And do you deal with all inches then?
All inches, yes. This stick is 48 inches. I need 15 first place trophies, which are going to be a 6-inch piece. And so Ramon has to calculate that. He has to say, okay, I need 15 6-inch pieces. How many do I need to get out of the 48-inch stick? So that tells us he can get 8 pieces out of one 48-inch. So the next piece, he can get a total of 15 pieces out of 2 full sticks.
And so once you have it here, Ramon, what would you do?
So what I first do is I get the figure on top, and then put the adapter and connect it to the rod, which is the same measurement as the column. I put the check ring to make sure it doesn't move anywhere. Stick that in there, then I get the base. I get my nut and my screwdriver and just tighten it down. Once I get it like kind of snug, I make sure that it's centered, and then I just give it a couple twists.
And then obviously your plaque would be going.
Correct. Yes, it would go right there.
Wow. Obviously, I'm seeing tools and things.
Mm-hmm.
Tools are obviously necessary, right?
Absolutely.
And with Megan, it was graphic.
Yes.
What are, if a student wanted to start in junior high, what would you say were the most specific things important for students to get into this business?
I would say a lot of it, like mechanical engineering, wood shop, anything that teaches you to work with your hands, measuring, learning how to measure is very, very important. A lot of people don't understand the difference between a 1/2 inch and 3/4, 5/8 to an 1/8. They don't understand the difference. So if you learn how to measure, you learn how to use your hands, it's a very good tool to have here.
So definitely measurement. And then over here, real quick, there are some beautiful things that you guys have put together.
Yeah, just some different, a lot of people think we're just a trophy and plaque in a store, but we do so much more. We do customized medals, we do customized trophies, you know, everything is customized that we do here. We engrave boxes, and that Megan's laser that you saw earlier. We even do these Yeti mugs, and we can put a logo on the Yeti mug.
Well, thank you, and thank you for letting us come today and see everything that you've done. And again, thank you for our tiles. They're absolutely beautiful.
Great, thank you.
Thanks again.
Thanks.
And back to you at the studio.
All right, thanks for that, Marylou and Randy out there. Hey, we do have phone tutors available until 5:30. All of the students that phone in and students out and about when they're doing problems have their names entered into a drawing, and that every single day is for tickets to go see the Bakersfield Condors. So, with the help of Jocelyn right now, go ahead and reach your hand in there and pull out one of these students' names, and we'll see who's going to the Condors. Can't look, just reach your hand in there. And can you read that off?
Jocelyn.
From Stern Middle School. So there you go. So congratulations to Jocelyn's got herself 4 tickets to go see the Condors. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.